engineer with Agilent located in Santa Clara, California. Raphael's focus is developing GCMS methods for various fields, including, but not limited to, forensics, food and flavors, fragrances, petrochemicals, pharmaceutical, and environmental analysis. All right, I believe we are ready to begin, and it gives me great pleasure to welcome Raphael Acosta.
Thanks, Rita. It's great to be here today, and thank you all for joining us on this day to learn more about MassHunter acquisition software for GCMS. Today's series will focus on MassHunter acquisition for MS analysis. What we'll do is focus on the design layout and ensure that you gain the most productive experience while using MassHunter acquisition software. All sessions will be conducted live, and they'll be using the latest version of MassHunter workstation software. Today, we'll focus on creating a method from scratch in terms of GC acquisition, mass spec acquisition. We'll focus on the parameters that are important to make a successful method, as well as, most importantly, tuning and air-water checks of the mass spec. We'll also go about how to set up a sequence and running a sequence using MassHunter acquisition software. And now I'd like to begin. So here we have MassHunter acquisition software. To a first approximation is 99% equivalent to MSD TempStation, and this is the current acquisition software for Agilent 7000 series triple quad GCMS MS. As you notice here, we have our GC parameters. And in this particular view, we have the parameters that we are accustomed to seeing in terms of setting up a GC method. What I'd like to do in this particular event is focus on those parameters that I notice customers miss the most, that they're not aware they exist even in their TempStation and MassHunter as well. For example, here we have our ALS parameters, in this case, our front injector. Ensure we have enough sample washes and such to ensure that we have no carryover. Also, if you have a limited volume, you could go ahead and set the sample depth here, make this number -1. And if you have a low volume in your vials, in your GC vials, you'd be able to aspirate the 1 or 2 microliters more efficiently. Focusing on the inlet, our multi-mode inlet, which gives us the capabilities of doing everything that a splitless inlet can do and more, allows us the capability of having cold splitless injections. So, for example, we have the ability to program this inlet at a low temperature to ensure that we have accurate transfer of our low boilers in our mixtures we're trying to analyze. But most importantly, when working in the splitless mode, we have the septum purge flow mode here that a lot of customers are not aware of. And what this does here, the default is standard, and when in the standard mode, the septum purge flow is on continuously, even throughout the splitless injection. However, when we make this into the switch mode, the septum purge flow is off for the duration of the injection to maximize transfer into the analytical column. Okay? In terms of column configuration and flows, as in this particular case, we have a GC triple quad attached to MassHunter software. And what we see is we have 2 columns. We have a 5-meter column and a 15-meter column. It is very essential to configure the proper column here in the Configurations tab to ensure that your column is calibrated. What this does is it ensures that if you make any maintenance to your column and clip a few inches off, your retention times will maintain the same. So you can set this length here, 5 meters, okay? And now our column is calibrated. Or if you perform some maintenance, you will go ahead and say calibrate and say adjust lens and say I removed 0.25 meters. It's a lot, but go ahead and do that, and it'll calculate and calibrate your column accordingly so that your retention times remain adequate for your analysis. So in terms of what is different here, so far it's very similar to what you're used to seeing in your MSD chem station analysis. However, the engine, the background, it has been reworked. The user interface is the same, and the features are still there. Okay, so we have flow. We have our flow set up in this particular configuration. We have a 5 by 15 configuration, so we have a 5 meter column and a 15 meter column. If you notice here, the flow for the first column is 1 mil a minute, and the flow in the second column is 1.2 mils per minute. These columns are attached to one inlet via a 3-way splitter, an OxyPC 3-way splitter that allows us to connect the two columns together. Okay. In terms of setting up your oven parameters, that's still very similar to what you're used to doing today. And the transfer line temperature is still controlled from here. If you have events or signals from secondary detectors such as EZD or FID, you can set up those there. And we have backflush conditions if you want to eliminate your matrix, your heavy matrix from reaching your mass spec source. You could go ahead and set up those conditions here. But what I like to do here, the takeaway message here, that in terms of the GC parameters for MassHunter acquisition, they are pretty much identical to what you see today. Okay? So here.